Hello and welcome to this video tutorial. We're going to be taking a look at basic right triangle trigonometry and some geometry angle relationships, as well as a quick review of area calculations. Now, please remember to pause or rewind the video as you need to. If you are brand new to this kind of math, please make sure you see me individually, and I will make sure to get you caught up and feeling better about it. Now, just to remind yourselves, when you're dealing with trigonometry, which is what we're starting with in question 22 and 23, one of the most common techniques that many math teachers will show you is an acronym that helps you remember your trig ratios. The acronym is, of course, called SOHCAHTOA. Which can be broken down into the following. S stands for sine, which is equal to the opposite side divided by the hypotenuse. Okay, C stands for cosine, which is going to be equal to the adjacent side divided by the hypotenuse. T stands for tangent, which is going to be equal to the opposite side over the adjacent side. So if we look in 23, theta is the angle here, 27 degrees, and we're given the hypotenuse of 15 meters. We got to find A and B. So to find A and C, so we know C equals 15 and theta is 27. So what I can do is I can set up a cosine ratio because this is adjacent and this is hypotenuse. So the cosine, this will help get us side B. The cosine of 27 degrees would be equal to the adjacent side, which is A down here, over 15. Now, to get A by itself, all you simply have to do is multiply both sides by 15, okay, and we're done. So we get 15 cosine 27 degrees, which gets you a value of about 13.4. So side A is about 13.4 meters. Okay, now part B, to get side B rather, okay, now yes, you could use Pythagorean theorem, but at the same time, I want you to try and practice your right triangle trigonometry. So for this, I could use those two sides, which was the opposite side and the hypotenuse, which means I'm coming up with a sine ratio. So sine of that 27 degrees would be equal to B, which is the opposite side, over the hypotenuse, which is 15. Again, to solve for B, you're going to multiply both sides by 15, just like you did last time. Cancels, cancels. B is equal to 15 times the sine of 27 degrees, which is roughly about 6.8 meters. Okay, now for 23, we're really doing the same thing, we're just given different values. Okay, so let me just replace those values. Okay, we are given side A is 15. 15, not meters, centimeters. And we're given an angle of 57 degrees right here. So we got to find side C and side B. So if I want to find side C, the hypotenuse, notice I got the adjacent side and I'm looking for the hypotenuse. Adjacent and hypotenuse would be a cosine ratio. So I could start with cosine of 57 degrees equals the adjacent side, which is A, 15, over the hypotenuse, which is C. Now to solve for that, we use the switcheroo, which would replace the denominator with the other side. So C is equal to 15 over cosine 57. And we roughly get about 27.5 meters. Now, to get the side B, we can use a tangent ratio this time because B is the opposite side and A is the adjacent side. So we can go tangent of 57 degrees equals B, the opposite side, over 15, the adjacent side. Multiply both sides by 15. And B is equal to 15 tangent 57. And we get roughly about 23.09 or about 23.1 meters. Again, if right triangle trigonometry is something that is brand new to you, please make sure that you see me so that I can break this down in a much more detailed way. Number 24 calls upon similar triangles. Now in IM2, we learn about various similar triangle theorems that help create proportionality or similarity between different triangles. So you do see that there is one big triangle here that has a 30 degree angle right there. But then you also see that there is another triangle that's right there. Wow. Turns out that if you take this triangle here and you rotate it like that, and then you flip it the other way, you actually get this triangle right here, which means this angle here is the same as that little angle right there. Now, there's another way you can kind of prove it. Over to the side, I'm going to sort of redraw this, okay, like this. Okay, I've got a 30 degree angle. I'm going to put the box on here. Instead of drawing the arrows from the middle of it, I'm going to draw the arrows from the bottom of it just to make it a little clearer, okay? That would be a 90 degree angle there. Let me go ahead and create the rest of this triangle here. That's a 90 degree angle there. That's a 90 degree angle there. Now, if you look at the angles that are created there, well, if this is 30 and this is 90, that means this angle has to be 60. Now, if this is 90 on this side, that means this angle plus this angle has to add up to 90 as well. And so if this is already 60, this remaining angle has to be 30, which is going to be always the same as the incline. So theta equals 30 degrees. Okay, 25. What is the area under the curve? Well, when you see curve, that is just a generic word for graph, okay? So we're going to see this trapezoid here, and let's break this trapezoid down into two familiar segments. How about a rectangle that I'm highlighting in yellow and a triangle that I'm highlighting in blue? So we're going to do the two areas separately, okay? Now, to do the first part, we're going to go and we got the base, right, times the height. So let's go 15 times 18, and we get 270, okay? And we'll talk about units in a minute. The units for V would be meters per second, and the units for T would be seconds. Well, the height of the triangle is also 15, but the base is going to be 25 minus 18. It's going to be that leftover, right? So if I go 25 minus 18, that means the base here is 7. So let's go base, height times base, divide that by 2. So 15 times 7, take half of it, and we have 52.5. Now add those up, and the area would be 270 plus 52.5, and we get 322.5 square units. Now, what are those units going to be? Well, if I'm multiplying, I am multiplying meters per second, that's this unit, times seconds, that's that unit. You can see the seconds cancel, leaving you with meters. So that right there would give you, yes, it's square units, but when you multiply them, it would give you essentially 322.5 meters. Okay, now what that represents is how far you went. How far you went in a particular direction is called the displacement. Very similar to distance. Distance relates to the length of travel in any direction, just the length of any 2 points, any 2 positions. But if we look at your change in position going in a particular direction, we would refer to that as displacement. Okay, I hope you found this video tutorial to be helpful, and that is all.